right, let's get into this. So a few announcements, and then we'll get into test cases for task 3. So the voting is ongoing for review week. We're kind of getting a tentative schedule. Some of these are fixed. Building a project from scratch, I'm not sure if that'll go here, or both days. That might just turn into a 2-day thing. But the rest of these are fixed. The TAs are planning to come in that first Wednesday, OOP and Python. I want to get that out of the way right away. Then genetic algorithm, that'll be the last thing. That's getting a lot of votes. Of course, if there's a huge swing in the votes, the schedule will start changing around, at least the 2 voted ones. And number 3, it's kind of a toss-up for what number 3 is going to be. The project from scratch, like there's quite a few suggestions that I'll roll into that. We'll start a project from scratch. We'll use Git to share it on GitHub. We'll include a GUI in it, and we'll deploy that as a desktop app. And then after all that, the next suggestion, I think there's like a close, it's a close race between what that next thing is. And that is a lot for one lecture, so that might just take 2 lectures. But we'll kind of see how that goes. I could definitely fit it all in one lecture, but it would be a lightning quick lecture. So if there's no clear like number 3 thing, something that goes here, then I'll just take 2 lectures to do this. And Paul as well. Paul's going to cover the same lectures. So there's that. So get your votes in if you haven't yet. Make some suggestions, etc. We have course evals. Yay, it's course eval time. So will the Gen Algo solution be recorded? I mean, I can't upload it to YouTube, of course. I mean, maybe. I don't know. Does it matter, though? Will any of the bonus topics be recorded, rather, besides the TA1? The TA1 might be. I'll talk to the TAs whether they want it recorded or not. If they don't want to and they want to be really candid, then no. The Gen Algo solution, I don't mind it being recorded, but it might not go to YouTube, but it might, because I might be retiring that assignment, that objective completely. So it'll depend on that. The rest of them, all the ones that I do, will be recorded with the possible exception of Gen Algo. Even if I don't re-upload it to YouTube, it'll still be on Panopto. I'm not going to hide any of my stuff. But the TAs, depending on what they want, they might just not want to get in trouble if they badmouth a professor. I'll protect them from that and remove it from everything. All right, but we got course evals coming up. You might not have heard this spiel too often, so I'll make sure you all know what the course evals are. You're starting to get the emails. You're going to get spam of fill out your evals, and I'm going to spam you right now, and I'll probably say this like every lecture until the end. But the course evals, this is a way for you to give us feedback. Paul and I, well, I guess your feedback would be just about this section. But Paul and I have access to each other's evals, so it's an interesting thing. But for us. But anyway, it's a way for you to give Paul and I feedback on the course, the structure, how we, anything you want. We do take these seriously. I read all the course evals, and a lot of what you see in the course right now is a reflection of the course evals. I read through the course evals. I'll restructure the course each semester, at least make tweaks and changes where it's necessary. And that's how the course became what it is today. It used to look quite a bit different, same content for the most part, but the structure, how it's presented and all that stuff has improved based on student feedback. So this is your chance to make that next incremental improvement, make that next change for next semester, and help the future students. Anything that you didn't like about this semester especially, how can we improve it? How can we take that thing that you didn't like, remove that frustration, and replace it with something that's still going to satisfy the learning objective, so you're still learning what we need you to learn, but to make your life a little easier in the process. What can we do? I want your ideas. You've been through it. I want to hear your experiences from the front lines. We don't get any information about these course evals until after final grades are due. So if you're worried, I don't want to say Jesse's an asshole because then he's going to lower my grade. We can't see your feedback. We can't see your responses until after final grades are due. So the idea is that no matter what you say, if you all have really bad things to say, I can't retaliate in terms of grades. And then even after final grades are due and I have access to the results, it's still fully anonymous. The UB does a lot to protect your Protect your privacy with these so they do know, so I don't know anything about who said what. All I have is aggregate data. That means before final grades are due, the only piece of information I have, the only piece of information they give me is the response rate. So I know how many of you have filled it out, but I don't know who filled it out. So I want to incentivize you to do this. You've probably seen this in other courses. We call it course eval bribes usually. My incentive to get you to fill out this thing has to be based on the percentage of the response rate. And here are the incentives that Paul and I agreed to about 10 minutes ago. We finally finalized what we want to do for incentives. So here they are. 60% drop a lecture question. Pretty self-explanatory, I think, on that one. We'll just drop a lecture question to boost your percentages. And you'll get to use up to one recovery opportunity that you haven't used. So if you've already used 4, this doesn't do anything. But if you have an unused recovery opportunity, you can effectively cash that in for an extra expected deadline. So if you got 5 expected deadlines, but you got a few recovery opportunities in your back pocket, one of those turns into an expected deadline, and you get that application objective for that. And probably the big one, Project 1, the application objective will be reopened until the morning of the last day of classes. So if you didn't get the application objective on the homework, you get another crack at it. You can still submit until the morning of the last day of classes. 70%, 2 and 2, projects 1 and 2, 80%, 3 and 3, projects 1, 2, and 3. So we get to 80%, you still got another crack at genetic algorithm. If that's your difference between having to take the final or not, or whatever decision, whatever difference that makes to you, this is how you can earn an opportunity to get that. So all the incentives are related to application objectives. I don't want to compromise the learning objectives. Like that's what I need you to learn to be able to progress through your CS career. But you can earn application objectives through these incentives. So get your feedback. Give me that feedback so I can improve the course for the next semester. And I'll give you some extra chances to improve your application objectives and therefore your grade. This will be on a per section basis. And I'll update the current response rates for each section as we go through. We're at 2% before this lecture. And this is the only information I get. I get the response rates for each section. The total numbers do not include all the resignations. So anybody who resigned, that does not count against your response rate. So it's only the survivors who matter for the response rates. If we refresh, hopefully this is looking a little bit better. And I absolutely hate that this is out of order. A, B, C, D, and then CC 312. So I'll update that periodically. I'm not going to do it right now. But we can see the response rates. We're at 7% now. A few of you did it. Thank you. All right. Any questions on any of that before we get into test cases? Yes?
What should we do for Paul's evaluation?
So you can't evaluate Paul. He's not your instructor, so you can't evaluate him.
Do we put anything down?
If you can put it in in the open-ended questions. If you want to talk about Paul's section, by all means. We'll have access to each other's, and if he doesn't read mine, I'll be like, hey, Paul, I got some feedback for you. This student said they watched your videos, and this is your feedback. But don't the quantitative scores don't mix me and Paul in there. For the quantitative, when it asks, how was your instructor, that's me. If you didn't like Paul, don't hurt my score. If you liked Paul, don't help my score. Just so you know. Just so you know. I don't want blame or credit for what Paul did on my quantitative. But in the qualitative, the explanations, by all means. Any other questions on this? What was the semester drop rate? I guess you have it on the screen. I did, at least. We started, it was about 100 in each section. Give or take a few students. You can find the enrollments on the hub or wherever, the hub or the catalog.
Which one are we out of the four? Out of
B.
the five, sorry.
B.
Oh, 7.
I mean, evals just opened up, though. Give us some time. And if I refresh, a few of you might be doing them right now. Yeah, 11. So a few of you are doing them right now. But I mean, we just decided on the incentives. Once the incentives are out there and everybody knows the response rates have a big spike up, then they flatten out for a while, and then we'll hopefully eventually get to 80%. We got to get to 80% before the morning of the last day of classes so we can unlock that genetic algorithm. That's the goal. We start at somewhere around 100. It's roughly 20% drop rate.
Right.
Any questions? The rest of the time I'm just talking about test cases for task 3 and the AO if we can get to that one. Can we earn 2 expected deadlines if we reach 70%? Yes. Yep. Did I explain that, right? So it's up to 2 unused recovery opportunities. So if we hit the 80% and you have 4, maybe you didn't use a recovery opportunity at all, then that turns into 3 extra expected deadlines. So if you needed, between the expected deadline and the actual deadline, you needed that time, but you never needed more than that. You didn't go beyond the expected deadline. Paul and I agreed that we're happy with giving you some credit for that and helping you out on the AOs. But if you always pass the actual deadlines, then you really didn't have that time management to really get the spirit of the expected deadlines. But if you didn't use your recovery opportunities, you've fulfilled the spirit of the expected deadlines, is the whole idea with that one. But yeah, you can get up to 3 if we get to 80%. What is Jesse Hartloff is watching? Are we allowed to mention which TAs were really helpful in the evaluation? Yeah. Yeah, so when you have that open-ended, like what did you find helpful with the course, and you say Paul's lectures were great, TA office hours were great, I'll bite my tongue and not say a specific TA. But TA, whoever was amazing, but Jesse sucked, that's fine. Whatever you want to put in that open-ended, whatever actually helped you out in the course is going to be great. That's great feedback. I really enjoy when you call out TAs by name, by the way, in a positive way, because I can know which TAs, like, I'll usually tell the TA, like, hey, you got a shout out, and it makes their day too. It's a really positive thing for us. And if you want to call out a TA in a negative way too, I still want that information, but it doesn't make their day exactly. Jesse Hartloff is watching. The domain is jesseIsAlwaysBeWatching.com, which is for 312 for lecture today. I showed how to get a domain name and deploy a website out there on the internet, and I let the students choose the domain name, and that's what they ended up with. What data structure memory diagram should we review for the quiz? Linked list and trees, not graphs. I never did a memory diagram with graphs. It won't be on the quiz. All right, so let's do test cases. So task 3 test case I'll be honest, it gets kind of tricky, but hopefully we can clear up any confusion today and get you through this with ease. So for this one, we want to find the distance between 2 grid locations, which are XY coordinates in the grid. We want to find the distance between 2 of them while avoiding walls. So this is the number of moves, like if we had discrete movements where you hit up and you go up by 1 grid location, then we want to find how many moves it would take to get from point A to point B without hitting any walls. This is effectively the distance, and when we get to the AO, we'll find the actual path. This is effectively a maze solver. You should be able to go through any arbitrary map while avoiding any walls. For task 3, we just want to find the distance of that, and let's talk about test cases. So let's set this up. Task 3. Task 2, there were no test cases. required. I just kind of talked about it when we went to the code for that one. But let's talk about task 3. And I don't know where my task 1 test cases went. I did code some up, right? I thought I did. Maybe it's in a different repo. I'm not going to look for it. So this is the first one where we have to work with the AI game state. So the AI game state class gets a little clunky to work with, if that's the right way. So it works a little bit differently than classes we've seen in the past. We need an object of this type, but there are no constructor parameters, and there are default values for the 4 state variables that we're interested in. So you need to do is create an instance of this and then set the state variables to whatever you want. And we have 4 things: the level, width, and height. You have to set these. You can't leave these at 0. And I'll explain why. Player locations, this you worked with in task 1, creating a linked list of player locations. So that's old hat for us. And then wall locations, a list of grid locations, which are the locations of all of the walls. So when we do this, when we write the test for this, the first thing we need is an AI game state. So I like writing this in a helper method. I'm going to design my own game board, pick where all the walls are and all that. I'm going to design my own game board, and I'm going to write a method to create it and return it as an AI game state. And then I'm going to use that for all of my tests. In fact, I write one of these, and I use them for all my tests for task 3 and the application objective. So, and you can write more than one if you want, but writing one and then using that in all your tests will work. So make, I don't know, game state, returns an AI game state, which is separate if you're wondering why I call it AI game state. There is a game state object also. This one is for the communication between the client and the browser and the server in Scala. So for that, I use JSON, and I don't want you to have to do all that. I used to require JSON in this class, and it's like a lot of the things I cut, it's just an exercise in tedium. You don't really learn much more. You just learn how to suffer through something. The course evals have said in the past that it's horrible and pointless, so cut it. So we want a game state. So that's why AI game state exists. It's the same information, but in a more friendly way to access. AI, this is going to be of type AI game state. We're going to create a new AI game state. There's no constructors, so we don't need any arguments, but we can have them if we want. And then we're going to set the values that we want. So game state dot, these 4 values we want to set to whatever we want them to be. So let's set level width. I'm just going to create a 10. I guess technically height's optional. 10 by 8. And then we want the player locations. I'll save that one for last. Game state dot. Actually, I don't have to save this for last. I can just set it equal to null, so it's an empty list. Oh, apparently I can't. New. Oh, shit. Linked list node of player location. New player location 5.6 3.4 player 1. Null. So let's just get that set up, just so we don't have any errors. So we actually have a player location list. And why are you still mad at that?
Because game state is not a dot at the end.
It's what?
State isn't like there's a dot, like at the line above.
The line above.
Oh, yeah. Thank you. Yeah, because I have an error here. The error is just showing up at the different spot. So, because I didn't finish this thing. So this is going to be a list of new grid location, I don't know, 4, 5. So we want to set this up. And then in our tests, the first thing we'll do is fail game state equals make game state. And then we'll have our game state to be able to test with, and we can check our grid locations and then get the distances between them. That's what we're building up to. Width and height, the width and height of the game board, these are required because when we have our level as graph method, we are using the level width. Oh, and the level height. We are using both. The level width and level height, if you have these set to 0, you don't get a graph. You don't get anything that works. You have to specify what the width and height of your level is, or else things are going to break when you try to get this graph. All of your, well, I guess not. All of this will be zeroed out, and you'll just get the X location. You'll have conflicting IDs and non-unique IDs. Everything just breaks. So you have to make sure you set these. It's one of the most common office hours questions. Just forgetting to set those, and then everything breaks and wondering why. Just make sure you set your width and height. Hopefully, mentioning that, we don't get the questions this semester. And then wall locations is where all of the walls are going to be as XY coordinates. And then player locations, like I said, we talked about that before. Now at this point, you have to design your level, figure out where all your wall locations are. And for this, I recommend getting out of IntelliJ and heading over to a spreadsheet. This is what I did in my solution. This is what I recommend you do, is it can get tough to spot bugs or even build the level in the code only. You don't have any way to visualize it. So I strongly recommend getting into something where you can visualize your level. So if we go to a spreadsheet, of course Google Sheets in this case, resize it so it squares, and start indexing. It's a weird, I don't know. The game board, the grid. So I went to 10. I don't remember if I include or exclude. I'll exclude it in here. The endpoints, and then we went to 8. So we have a So we have a 10 by 8 grid. And what I want to do is visualize where all the walls are. By the way, I forgot to mention, I mentioned this briefly in the doc, but the y coordinate starts at the top and goes down. The positive y direction is down. So if that factors into your testing, if you get it upside down, I think most of it just works out anyway. Your board is just flipped upside down. But it starts at the top and positive y goes down. So if that does affect any of your setup, any of your code, any of your testing, just be aware of that fact. This is common across computer, do I want to say computer science? But it's common across anything visual. This monitor, this projector right here, pixel 00 is the top left corner. Like that's just the way things work. Images, movies, videos, anything. For some reason, the convention is just the upper left is 00. So for what it's worth, that's just how it works, and I stayed consistent with that. So this is 00, 10, 20, 21, all the way out to 97 out here. And then I just want to build a level. So for this, of course, it's just barely off the screen. I'm going to create my walls. I'm just going to design a little level. And I want to do something that's going to be tricky for my AI to navigate. So let's create a little horseshoe here. So then I can have like the distance between this point and this point. It's not going to be 2. I want to make sure that it goes around the wall. And you can have this as complex as you want, but at least enough so that you have some test cases where there are going to be walls in the way. And then for the application objective, put a player here, and like a player here, and make sure closest player is going to find this one, not this one. things like that. So setting up your test cases to take advantage of that. So now that I have this set up, I'm going to go back to my code, and I'm going to code this level design in my wall location. So I have 3, 1. Let me set this up. What do I do? 5, 10. I regret doing so many of them now. I don't think that's enough. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 4, 1, 5, 1, 6. I can do this. 6, 1. 2, 3, 4, and 5. So I have all of my wall locations set. And at this point, I'm ready to write some tests. So I have this board set up in this code. And that would be a pain to do if it's possible you can do it. You don't have to use Excel, but it's a pain to do if you're not visualizing in some way. And I like seeing these in office hours. If you come to office hours and you say, look, this is my game board, I got it all sketched out, and I got it in the code, and I'm just not getting the right answers, it makes it a lot easier for myself and the TAs to quickly get on board with what you're talking about, with what you're asking, if we can visualize the thing. All right, so I'm ready to write some test cases now. So I want a new AI player. Equals new AI player. I need an ID. Let's say player 1. That's all a player needs, right? Yeah. And I want to say player dot distance avoid walls. Where are we? This is the one I don't give the starter code for. Distance avoid walls. Of course, that doesn't resize any way that I want it to. Distance avoid walls. Wow. Why is there not? Okay. It takes 2 grid locations. And I want to choose my test case. Let me just fill these in with something so we can get rid of this error. The error is bugging me. Grid location 0, 0, 0, 0. Now I should have an autocomplete. Create method is going to return an int. And we'll just stub it out to return 0. But it takes 2 grid locations, and returns an int. That's what I want. We're not going to worry about the code today. We're just writing some tests. But that gives me the ability to test my code. So I want to do distance avoid walls. I'm going to hard code this. This is where I would have a map of test cases and a loop, but I'm going to skip that. Result, which is an int, equals this. And I want to assert that result equals something. Let me expand this so we can see the grid locations. And now I'm going to go to my picture. I'm not going to even attempt this by looking at the code, because my goodness. And I want to start off with a test case that's really simple. 8.1 to 8.3 is a good one. Which should be distance 2, 1, 2. Now I should be able to get that one. I don't even need breadth first search or graphs or anything. This is a good test case to make sure that you're at least in the right direction. Because if you're failing this test case, you know that you did something terribly wrong. You got something really fundamental to fix. that you don't even have to really look at your breadth first search code. You got to fix something else. This takes a game state too. I didn't even give it the game state we created. Let me just make sure, just so I'm not showing the wrong thing here. Takes the parameters of type AI game state and 2 grid locations. Cool. So this should be 2. And then I'm going to take my test. I'm going to create another one. Again, you can throw your test cases in a map. That's fine. But I don't feel like setting all that up because it's not really what we're talking about today. You've seen me plenty of times set up test cases as a map. And now I want to finally get something to challenge my player. How about 5-5 to 7-5? If I have really incorrect code, that's going to give me 2. And one of my incorrect solutions just goes through that wall and doesn't care. That's going to give me 2. But the correct solution, 1, 2, 3, 4. We want to make sure that's giving us 4 for that path. Let's get another one. And then we can really challenge it. We can go from here, 4, 2. So let's say 6, 0. So 4, 2 to 6, 0. We got a few choices here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we should get 14. So that's a good, tricky test case because there are 2 paths, and one of them is just a little bit shorter than the other one. So this is going to make sure like your breadth first search isn't overriding the results. Like when you that you're not exploring that node 2 separate times, things like that. This is going to be a solid test case that's going to get rid of a lot of buggy code. You're going to make sure you're really putting it to the test. And then, of course, as many test cases as you need after that. For this purpose, this should be enough to really get you going. So I guess I kind of just gave away the test cases here. But the key thing here, make your game board. Make that game board, design it, put your walls there, create an AI game state for that board, and then start writing your test cases with a visual. See how easy that was, just counting the squares, counting the lengths of the paths? That's how easy that should be. If you're looking at just this, good luck. Like, holy hell. And you might also want some diagonal things here. I didn't do any diagonals in this one. I guess I should have. But yeah, trying to find, okay, what's the shortest path between 2 grid locations, and this is what you have to look at. No. I want to look at this and just count boxes. So much easier. Today will be the last lecture question, yeah?
Really?
All right, any questions on this setup? We're doing the whole damn thing then. So for the application objective, I'm going to have mostly the same setup, except I want to add some players to this thing. Equals list. And when I get some player locations in here other than this one that I have. So I have one player which is in a good location actually. So 5.6 and 3.4, we want to find which grid location this is. We don't actually care about the absolute positioning within the grid. We don't care about the sub-grid grid locations. if you will. But if we take the floor of each value, that's going to tell us the grid location. So I know 5, 6, and 5, 6, 3.4, that point that on this grid is going to be at 5, 3. So I know I have player 1 right there, and we're going to put that right on my map. That's where player 1 is. So let's get some more players. I want a player right across from player 1 because that's going to be a tricky test case when we're trying to find the closest player right on the other side of a wall, which would be distance 2. We don't want that to be the closest player that's returned. That's what our old closest player code that does Euclidean distance, that's what that one can return. That one's not a very smart algorithm. We want to actually look around the wall and find the answer. So let's put another player, hell, right here. Why not? So 3, let's get a little further away. 3, if I ask 1, what's your closest player? It better be saying 3 and not 2. You know what? I don't like it there either. Let's put this right here, and let's put another right here. That's a pretty tricky test case. So I have these 4 players. I want to get these players in the list. So list equals new linked list node, yada yada, of player location, new player location. And I'm going to choose random decimals for each one. So 2, 7.1, and just make sure that they're in the right grid location. 3.9 list. Three is going to be 7.8, fine, and 6.3. I don't know. 4 is going to be 2 point something, 3 point something, 3, 4. So I have my players where I want them. They're at the right grid locations. Now guess what I get to do? Never look at this list again. I don't give a damn about this list unless I'm debugging. I think that's where my bug is. Those player locations are at these grid locations. I'm never thinking about that again. I'm just looking at my visual and then generating my test cases from that visual. I like to visualize things. So my test case, I'm going to ask player 1, what's your closest player avoiding walls? Here's your game state. That's all this thing needs. And it's going to get a player location. Result.id. And then ask for the ID of each one. So if I ask 1, what's your closest player? I should be getting 3. That's distance 1, 2, 3, 4, 5. 2 is 6, 7, 8. 2 is distance 8. And 4 is 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3 is what I expect. Let's copy the guts of this. I'm going to want one more. I'm going to ask each of these 4 players what's your closest player, because why not? I got all this set up. Writing the test cases is easy enough once you have a solid setup. I'm going to ask player 2, what's your closest player? I'm expecting 3. Good. 3, what's your closest player? I'm expecting 2. Notice it's not symmetric. So 1 was 3, but 3 wasn't 1. And then 4, what's your closest player? And this should also be 3 if I set this up right. So we're going to go here. We have to get to here regardless of the player. Or right here, I guess, kind of. And then an extra 3 or an extra 2. So it should hit 3. But let's count. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 4 is also going to be 3 for the closest player. So I'm making sure that they're going around these walls and actually counting the number of moves it would take to get to each player and finding the closest player while avoiding walls. That's what we want to do with this one. The second part of the AO, I won't go through that one. So I'll leave that up to you. I won't give you all the testing. But the next one would be finding the actual paths. Like 4 to 3 would need to find this path. 4 to 1, if 1 was the closest. There are multiple paths. Once we get to this point, we can go this way, we can go this way, we can go this way, or we can go this way. There are 3 optional paths that can be taken, and your code would have to accept all of them. This one's a little bit easier than the compute path that you've done in the earlier objective in task 1, because you can place your walls strategically to make sure there's only one unique path. It can save you a little time in testing. Whereas before, if you had any diagonal movements, you had to include multiple paths in your testing. But here, if I don't want to bother with that, I'm going to put a wall right here or right here, and then there's only one unique path. And then I just test, did you return that path? So you can be a little strategic for this one. Just to make our lives easier. We're programmers. We like to think of creative solutions to make our lives easier. It's why we write code to begin with, to have the computers do our work for us. Any questions on this? This is a lot farther than I thought I'd get with the testing.
Go back to
Yeah. Any specific part?
like the whole thing.
The whole thing. So the
I couldn't keep up.
oh yeah, if you want me to slow down, just let me know. When I stop for questions, like I actually want questions. Even if your question is like, just hold up a bit. I'm fine with that. So we're setting the width and height of the level. So I set it to 10 by 8. So that's giving me a 10 by 8 board. I'm choosing where all my walls are. So I have a wall at 3, 1. So I'm going to add a wall at location 3, 1. And then I have a wall at 3, 2. I'm just going to add all those walls. So these gray blocks here are my wall locations for this board. So this is what the board would look like if we coded this and then spun it up in the GUI. This is what our board is going to look like. And then we want to specify where all the player locations are. For task 3, I don't really care about player locations. We're just working with grid locations. So I set this just to anything, just so it's not null. And then I have my setup. So game state is going to be basically defining the game board. How big is it and where are all the walls? Then my test, I'm going to call make game state. I'm going to call my method. That's going to return this game state that I've created. So when I say make game state, I'm saying that board that I designed, give me a copy of that. Then I'm going to create an AI player because all of the methods that you write in this homework are in the AI player class. So we need an object of type AI player or else we can't call those methods because that's a class, not an object. Objects we can just call, we can say AI player dot call the method. Like we did like way back in Pale Blue Dot, we would just call the methods directly through the class or through the object. But now we have a class, so we have to create an object of that type to be able to call the method. So I'm creating an AI player, just giving it an arbitrary ID. I made it match the ID and the player locations just in case something might break if I don't actually have that player ID in the player locations map. But it doesn't have to be for this testing. If I reuse that game board for one of the other objectives, I might have to satisfy that guarantee that the player is in the player locations, just to make sure. So once I have the player, I can call that distance avoid walls, which is the task 3 method, the only method in task 3. That takes an AI game state, which we just spent quite a while creating. That's going to tell the player, hey, here's how much room you have to work with in this game, and here's where all the walls are. Here's where all the other players are. So now your AI player has all of that information. For task 3 and the application objective, you'll have all that information in the AI game state. You won't be able to, whereas the task 1 and task 2, I give you only the relevant information in the parameter calls. Here I'm just dumping you the whole thing. Here's the whole object that represents the game. Pick apart the information that you need. And I do that because you need the graphs, which levelized graph is in that object. And then 2 grid locations. So this is saying for this game board that we designed, for this game board, if I want to find the distance between 8, 1, this location here, come on, never mind.
Nice.
This location here and 8, 3, start at the origin, 8, 3, go down 3, this location here. So I want to find the distance between these 2 locations while avoiding walls. In this case, this is our first test case. There are no walls in the way. It's just the number of moves that if I had a player here and I was moving grid locations, how many moves would I have to take to get to the other grid location? I need to take 1, 2 moves. So I'm calling this to get the distance between those 2 grid locations in this map, and I'm expecting that result to be 2. Then things get a little trickier when there are walls in the way. So I made sure I have a test case 5, 5 to 7, 5. Now there's a wall in the way. It's no longer 2. We can't take this path. So we're going to go around. I can actually do it this way. I'm going to have to go around and take this path, which is 1, 2, 3, 4 distance to be able to get to there. So if I'm an AI player or a human player, and I can press down to go down 1, I can press up to go up 1, left to go left 1, and right, but I hit a wall and I can't move. What's the quickest way I can get from here to here? I'm going to go down, right, right, up. Quickest way, and that was 5 moves, or 4 moves. So I'm expecting 4. And then we kept going with a tougher test case. 4, 2 to 6, 0 was a much tougher test case. We had to find this path. Or no, it was the other path. I forget which one was the shortest one. But one of them was shorter than the other. And we counted boxes until we got the shortest path. So you have width 2 and height 3. Yeah, I mean, you're not saving anything, though. I mean, I have width 100 and height 80. Like that took me 0 extra effort. I don't know what you're trying to save by doing that. Which AO is easier, Project 2 or Project 4? I'd say Project 4. Project 4 is maybe not easier, but it's easier because you already have to go through Task 3, and it's not much harder than Task 3.